Hi everyone. So today we are going to solve a problem that is palindromic substrings. Means in this problem we need to get the number of substrings which are palindrome. So in this case we can see that A is also a palindrome, means every character would be a palindrome. So A could be a palindrome B, and A is also a palindrome, but here A, 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 B. So A, B. All characters are palindrome, but let's have palindrome of size 2. AB it's not palindrome, BA is not palindrome, AA is palindrome. AA is palindrome, and we can also see that ABA is also a palindrome, ABA, and BAAB is also a palindrome. So how we will find the palindromes which are substrings of this strings, or how we are going to find the substrings which are palindrome. So the naive approach that might come into your mind, that is generate every substring of this string first, like A, AB, ABA, AB double A, AB double AB, and substring starts from this B, B, BA, B double A, B double AB, then start from A double A, double AB, start from this A, AB, and this last B. So this is, we generated every substring of the string. Then we can check that it is palindrome or not. A palindrome, AB not palindrome, AB a palindrome, AB double A is not palindrome, AB double AB not palindrome, B palindrome, no, no, yes, 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 no, yes, no, yes. So the total number of palindromes we have got is 1, 2, 3, 4, 5, 6, 7, 8. So we should return 8, right? So in this case what we have done, we have generated every substring of the string. So for generating, means the total number of substring of a string would be n of order of n of square. Why? If the length of string is n, then the total number of substrings would be n of square, right? So in this case, for generating every substring, we took n of square, and for checking that if it is a palindrome or not, it is taking order of n. So the total time complexity of this algorithm would be n of q, right? So can you think of any algorithm which could take lesser time complexity than this? Let's observe something. How we are checking that if a string is palindrome or not? We can do this by, we have two approaches. Like if ABA is a, we need to check if it is palindrome or not. We could have two pointers from the start and from the end. If it is equal, we shift both the pointers like this. But in this case we are starting from the end points. Let's just start from the middle, right? So if BCACB, let's start from the middle. We have two pointers pointing at the middle. Let's shift them, right? In this way we can calculate the substrings also. How? I'll tell you. First, check. A, it's a palindrome. Go side by side. CC equal. So CAC is also a palindrome, right? Then go aside. B equal. So BCACB is also a palindrome. So in this case, what we have done? We have checked that it is a palindrome or not, and we also have checked that if A is the middle element, how many substrings could be palindrome. Let's see how. B, C, A, C, B. Here, if we have our 2 pointers at the middle element, we can say that A is a palindrome, so we can count to 1. Then we go aside. C and C are equal, so we can say that CAC is also palindrome. So we can count 1 substring also. And if we go aside again, we see that B and B are also equal, so we can say that BCACB is also a palindrome. So we can raise count by 1, right? So this approach, we are going to calculate the number of substrings which are palindrome. How we are going to do this? Let's get our original string, that is AB. Okay, so take AB, right? So first consider A is the middle element, right? So A is the middle element, both pointers are here. We go aside, but A is a palindrome, so count raised to 1. We go aside, string finished, there is nothing in the left of A, so we shift both our pointers to B. Now B is the middle element. B is palindrome, so we can count 1. We go aside of B, A are equal, so this is also palindrome, right? So we can raise the count by 1. Then we again go aside, but here the string is finished, so let's have A is our middle element, right? So A is a palindrome, we can count it. Now go left, go right, go left. A, B, not equal. So there would be no palindrome if we also include this A and B. Because B and A are not equal, we can not explore right and left. Let's have this A, right? This A is palindrome, count raised to 1. We go right, we go left. B not equal to A, so now shift to this B, right? Both pointers here at B. We go right, we go left, string finished, nothing. So in this case, we had started like we have A, B, double A, B. We started from the middle point whenever there is a single middle point, right? Now this was the case when the substring is of length odd, because the middle was a single element. We were starting from middle element, but in the case when the substring is of length even, it would have 2 middle elements, right? So now iterate with 2 middle elements. So here A and B are not equal, so we are not gonna explore left and right. Shift our both pointers to B and A. B and A are not equal, so there would be no palindrome. Now shift both our pointers to here. We can see that A and A are equal, so we got one more palindrome. Now shift right, shift left. B and B are equal, so we got one more palindrome, right? Now we shift our pointers. There is nothing here, string is finished. So that is it. Now we had our two pointers here. Now have our two pointers here, A and B. A and B are not equal, so it's not a palindrome, right? So we have calculated for odd substrings and even substrings. So we have covered all test cases. So here we can see that 1, 2, 3, 4, 5, 6, 7. 7, right? Why 7? So here we found 7, but it should be 8, right? You can go back and see that we have not added 1 for this substring B at last, where we just explored a side of it but not calculated or counted this B. So there should be plus 1 for this B, and the total would be 8. So in this approach, what we are doing, we're going to every element or every character and we are exploring its left and right. So for iterating every character, it would take order of n time complexity, right? And for exploring its left and right, it would take order of n, right? So the total time complexity of this algorithm would be order of n of square, which is lesser than n of cube, right? Which we got here, n of cube. This was brute force approach, and here it is our optimized approach, where we are getting time complexity of n of square, right? So let's code it up. As we have discussed our problem and its solution, let's code it up. And in this case, the length of the string would be s dot length. And what we are going to do, we are going to iterate through every character and then explore its left and right? So for int I is equal to 0, I less than n, I plus plus, and let us write a method to explore left and right, and it would return int the number of substrings, right? So the two pointers would be int I and int j, and the string which we are exploring. So int n is s dot length, right? We would explore the string until any end comes to, means any pointer comes to an end. So while I is greater than equal to 0 and j is less than n, right? And let us have a count, int count is equal to 0, and if the characters are equal, then we just increment the count, right? And shift our pointers, I to the left and j to the right, okay? And if these are not equal, we can just return, else we can return the number of substrings we have got. So we can return count, right? And if the whole substring was a palindrome, it would come out of the while loop and we can return here count. This is a simple method. Now we are going to have two kinds of substrings. One is for odd length, one is for even length. So if we would declare int of answer as 0, right? And there could be answer. In answer we can add sol of pointers pointing to a single character, right? And string, this is for odd length. And for answer plus equal to sol I and I plus 1, the pointers for even length, right? This is for even length. And at last we can just return our answer. That's it. Means it was not so lengthy, not so complex. So let us see the code. The pointer string count is here, else returning count. Let's run it up. Let's see if we have coded it right or not. Why it is time limit exceeded? Sol and I and j string, n is s dot length, count is 0, while I is greater than equal to 0, j is less than n. If sii equal to sj, count plus plus, we are doing I minus minus j plus plus, okay. Else return count. We should have return count, not else count, right? Let's see. Yeah, it is working fine, and let us also try to submit it. Yeah, it's correct. So it was the lead code problem, but we also have the same our GFG, right? But here what it is saying that count whole palindromic substring present in the string, and the length of the palindromic substring must be greater than or equal to 2. Means we do not need to consider every character here, right? So in this case there would be only 3 palindromes. We can solve this problem again. Let's copy the code, exact code, right? And copy this solve function. You copied everything, but in this case we are not going to count every character. So we are not in the case like here. If there is A, B, A, right? So ideally for B, in the case of B, iteration of B, we should give both the pointers as, like, if the indexes are 0, 1 and 2, this is we should give two pointers as 1 and 1, right? Two pointers is 1 and 1, but we are not considering a single character, so we will give the left and right pointer of the current character. So in the case of B, we will provide 0 as left pointer and 2 as right pointer, right? So this is here we need to do the change. So in this case we will provide I minus 1 and I plus 1 pointers, right? So this will cover the condition that the substring must not be a length of 1. So now if we run the code and see if it's working fine, yeah, it is working fine, it's giving 3. Let's submit it up, and yeah, here we can see that it's correct answer. So thank you so much for watching. Bye bye.